Well, hi there, boys and girls. Today we're going to go backwards from the derivative of natural logs that we learned yesterday. And so we know this statement, the derivative of natural log of x is equal to 1 over x. And we also know that the derivative of the natural log of u, where u is any function of x, this is going to be u prime over u. This is what we learned yesterday. Now what this means is, if we are to integrate both sides of this statement, then we should get that the integrals and derivatives cancel. We should get that the natural log is the answer to the integral of u prime over u. So today we're going to add something special here. We're going to say that the natural log of absolute value of u is the answer to this. The reason that we put the absolute value on that is because natural logs cannot deal with negative numbers or zero. In other words, the domain for natural log is x has to be greater than 0. Or u has to be greater than 0 here in this instance. So 1 second, I've got a visitor, so I'm going to have to pause. Let me go down here and pause. Okay, we're back. Now, do you have to worry about these absolute value symbols? Well, sort of. On the multiple choice exam, they're almost always going to be there, so it's not like you really have to worry about that. But it's good to know that we have to put an absolute value on our answer. Okay, so this is our general statement. If we want to integrate 1 over x, the answer is natural log of absolute value of x plus c. Or if we want to integrate 1 over u, as long as we have du, this is also written as the integral of du over u. As long as we have this form, this answer is the natural log of the absolute value of u plus c. So this is what we learned. Now this is going to be the reason that we can finally integrate tangent. We know the integral for sine and cosine, we know the integral for secant squared, and we know the integral for cosecant squared, but we don't know the integral for tangent, but we are going to know it now, because we can rewrite this as the integral of sine of x over cosine x dx. So let's take a look at this. If I let u be cosine x, which is the bottom function, then du dx is equal to negative sine of x. What I have left to substitute for is sine x dx. You can see now again why we spent so much time with u substitution, because it's not going away. So I'm going to solve this equation for sine x dx. So I'll get negative du is equal to sine x dx. So I turn this into the integral of negative du over u. And this negative can come right out front in front of the integral, so it's negative integral of du over u. Now we know what this answer is. If we have du over u, let's go back and look at it. The answer is the natural log of the absolute value of u plus c. So my answer to my integral is going to be negative natural log of the absolute value of u plus c, where u is cosine x. So it's negative natural log of the absolute value of cosine x plus c. Now there is another way to see this. Because of your properties of logarithms that we talked about yesterday, this negative right here can be brought up here as an exponent on this argument cosine. And cosine to the negative 1 is equal to 1 over cosine. Now that doesn't mean arc cosine, that means the reciprocal of cosine. And the reciprocal of cosine is secant x. So you might also see this as the natural log of the absolute value of secant x plus c. Either one of these answers are acceptable. You have to know that they're equal to each other. Alright, so let's take a look at another example. What about the integral of cotangent of x? Well, we can rewrite this as the integral of cosine x over sine x, because that's what cotangent is equal to. And here I've got a fraction, so anytime you see a fraction, you might want to see if it's a natural log integral, because this is going to be one of your preferred integration techniques, because it's not that hard. If you let u equal the bottom, then du dx is equal to cosine x. And so we substitute for all of this right here, and we get that du is equal to cosine x dx. So this is a perfect natural log integral. It is du over u. I don't have to do anything to it. So this answer is the natural log of the absolute value of u plus c, where u is sine x. So now we have an integral or an antiderivative for cotangent. All right, now it's going to be up to you in class, in your book. I want you to look up the integral of secant x dx, and I also want you to look up the integral of cosecant x dx. This is yo business. You do this in class in the book. I'm not going to prove it to you because I have to do some other examples. All right, so let's take a look at another u prime over u example where it's perfect. What if I have the integral of 3x squared plus 1 over x cubed plus x dx? If you have a fraction and you can't separate it, I strongly recommend you look for, is it maybe u prime over u or some version of that? If we let u equal the bottom, x cubed plus x, then du dx is 3x squared plus 1. Oh yeah, that is nice because that's exactly what we have up there. So we just solve this for du and we get that du is 3x squared plus 1 dx. I've got another visitor, so let me pause this real quick. Okay, we're back. So this is a perfect integral. I've got the integral of du over u. So my answer is the natural log of the absolute value of u plus c, where u is x cubed plus x. So my answer is the natural log of the absolute value of x cubed plus x plus c. Now, is the absolute value necessary here? Well, yes, because x cubed can be negative. So it's definitely necessary there. You might as well just put absolute values on it all the time. It's not going to be a problem. Let's take a look at another example where it's not so perfect. What if I have the integral of 1 over 3x plus 2 dx? I have a fraction. It's pretty easy to see if it's u prime over u. It's going to be one of your preferred integrals with fractions. So if you let u equal 3x plus 2, then du dx is equal to 3. All I have left to substitute for is the 1 dx. So I'm going to solve this for dx, and to get 1/3 du is equal to dx. So this turns into the integral of 1/3 du. I'm going to put the 1/3 out here over u. So it is 1/3 the natural log of the absolute value of u plus c, where u is 3x plus 2. So it's 1/3 the natural log of the absolute value of 3x plus 2 plus c. So that is an example where we don't have a perfect u prime over u integral. And I think that's good enough for now, so I will see you guys tomorrow.